Hi guys, welcome to our online lab today. You guys are going to be going through this lab with me, and I'm going to be doing my best to show you all of the results so that you can kind of do the whole worksheet as if you were in class doing the lab yourself. And some of these things, as you'll see, you can actually do on your own at home. So after you watch the lab video, if you're maybe inspired to get your hands on some science at home, then hopefully this will help you know how to do that. So let's go ahead and start with the first mini lab here, stretchy water. So I've got my equipment here. I've got my beaker filled with water. Then I've got my pipette here. And then I need a square slide. So I've got those. This is the square slide, if you guys can see. It's just a little square piece of plastic. And so I've got that right there. So I'm going to suck up some water here. I'm going to do 5 drops. So let me slide this so that you guys can see it. I think right there is good. So we're going to do 1, 2, 3, 4, 5. Okay, so what I'm going to do is I'm going to slowly dip my finger and try to create a column of water here. I don't know how easily you guys can see that. Maybe if I bring it a little bit closer, this is the good part of having this here. So you want to create a column of water. That's about the best I can do. Maybe if I get more water on my finger, maybe that'll help. Notice I like barely have to touch the water and almost like jumps onto my finger here. All right, well, that's sticky water. Or no, that's stretchy water. I'm stretching the water. Oop. Okay, so go ahead and pause this video here and answer the questions about this little phenomenon that we're seeing. So what do you notice about the process of me creating that water column? Were you surprised at how far I was able to stretch it? What properties of water explain the ability for the water to stick to my finger so I can stretch it the way that you just saw? And then what's another example of that property of water? So those are those questions there. Like I said, pause the video, you can jump into the questions, and then we can move on to sticky water. So before we begin, make a guess. How many drops of water do you think can fit on this little square slide here? How many drops of water we're gonna be able to fit? Let's see here. So I've got everything wiped nice and dry. I'm gonna collect some more water in my pipette, and let's begin. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I'm gonna get more water here. So we're at 30. So far it's still on the slide. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, oh, 43. So the slide was able to hold 43 drops of water. And I don't know if you guys want to like rewind and then watch that. Maybe I'll edit the video to put a slow-mo in here, and you guys can see just how cool that was when you start adding the water in towards the very end. It almost like ripples on the surface. So those are those first 2 mini labs. That was sticky water and stretchy water. So now let's do slippery water. So I'm gonna go ahead and drop this into my little used bin here. Now I'm going to draw up, let me get everything out of here. Draw up, so this solution here, this is solution C. So I'm gonna slowly start dripping solution C into the beaker here. Let's see, maybe I wanna do a little bit more. Maybe this whole stopper is fine. Boop. Okay, well, let me show you guys a little bit closer. As you can see here, I don't know how well this will show you without it spilling out. It's kind of just staying right on the top there. It's just floating on top. So let me do another beaker full. or not beaker, another pipette full. Let's do, it's still right on top. Can you guys see how it's just like floating right on top there? So let's see what happens when I stir it. Whoa. Look, it breaks up into all of these little drops, but for the most part, they kind of stay together right on the top there. Keep going. Maybe if I like try and do this. Nope, still just doing its own thing, just staying right on top. All right, so now that we've watched this here, what do you notice is happening? What do you observe? Go ahead and write that down. And then if you had to make a guess based off of the way that this solution is reacting to the water, so it's not really mixing. Ooh, that's cool. Like we'll break up into some different dots there. Yeah, it's not really mixing, it's staying floating on top. So go ahead and answer the questions 3, 4, 5, and 6. When something doesn't mix well with water, what is it called? What does that mean? And then what is your explanation for why this solution C tends to just stay on top of the water? What do you think is going on here? So those are all of the ones that we're going to do with water. Let me put this away here. Okay, so now we're going to take 2 pieces of blue litmus paper. There's 1 and 2. And we're going to label them. This one is A. It's so thin paper, it's hard to label. And this is B. And then we're going to dip them into beaker A. We'll lay that flat. And beaker B. We'll lay that flat. So this is the blue litmus paper, and this is dipped into A, and this is dipped into B. Now remember, this is blue litmus paper. So if it's blue, well, it's blue litmus paper. It didn't really change color, right? But this one, it looks like A stayed blue, but B turned red, if you guys can see. It's not super clear to see here on the iPad. Let me see if I can help. Maybe this will help us see the difference. So, no, that doesn't really do anything. Okay, that's fine. So B turned the blue litmus paper red, and A just kept the blue litmus paper blue. So those are those 2. Now let's do 2 pieces of red litmus paper. 1 and 2. And then we'll label them again, A and B. We'll dip A into beaker A, and then we'll dip B into beaker B. All right, so let's look at these ones. Okay, so remember, this was the red litmus paper, and A, if you guys can see, was able to turn blue. So solution A turned the red litmus paper blue, and then solution B, it just stayed red. So the red litmus paper just stayed red. So for the questions here, remember for reaction for the blue litmus paper, A stayed blue, B turned red. And then for the second one, the reactions for the red litmus paper, A turned blue and B stayed red. So you can write those down and then answer the questions 7 and 8 based off of your results. Was the solution in beaker A an acid or a base? How do you know? And then was the solution in beaker B an acid or a base? And how do you know? Remember, you want to pay attention to the colors that the litmus paper changed. So then now that we've kind of done all of those little mini labs here, you guys can answer these questions. So there are some questions about water, and then there's questions about acids and bases, and there's not too many. All of the answers can be found in your notes. So when we go over these notes in class, you can also just have them saved on your Notability drive so that you can go through them, and that should be all that you need to answer these questions. If you guys have any difficulty or if you need to go back through any of the lab, then you're welcome to do that, or you can reach out to me, of course, over email, and I'd be happy to help you guys out. Otherwise, I will see you guys later. Bye.